Hi, in this video, we're going to talk about parallel vectors. So how do you know if two vectors are parallel? Well, they're going to be vectors that go in the same direction or opposite directions. So they have to be exactly the same or exactly opposite. Let's take a look at some examples. Let's say I want to identify two vectors that are parallel. Remember, if two vectors go in the same direction, they are parallel. So I can find that these two are parallel because they both go up and to the right, where they're going up 6 and right 2. Now, I could find two more that are parallel here because vectors that go in exact opposite directions are also parallel. When we look at these two, you can see one goes directly to the right and one goes directly to the left. So these are also parallel vectors. Now, what if I don't want to work with these graphically though? If I'm looking at it completely algebraically, I can tell that u and v are parallel if u is a scalar multiple of v. So u is equal to c times v, or c is that scalar multiple. Now, the way we can actually test this out and look to see if two things are parallel is when we are given the two vectors. Let's say in this example, I have u is 1, 5 and v is 3, 15. I'm going to pull out the greatest common factor from each component and see if the remaining vector is the same. So for example, in u, the biggest thing I can pull out of both 1 and 5 is 1. So it's really 1 times 1, 5. V, the biggest thing I pull out of 3 and 15 is 3. And when I do that, I get 3 times 1, 5. So now you can see that these both have the same base vector, 1, 5. So yes, the vectors are parallel. Let's try another one. What if I give you u is 8, negative 12, and v is negative 10, 15? Well, I'm going to pull that GCF out just like I did before. What is the largest thing I can pull out of 8 and negative 12? Well, hopefully you said 4. When I pull out a 4, I'm left with 2, negative 3. Now when I'm looking at v, I have negative 10, 15. What can I pull out of both of those? Well, I think I can pull out a 5, or I can pull out a negative 5. For our purposes, it is easier to make that first number a positive, because then we can be comparing apples to apples, if you will. So I'm going to pull out a negative 5, which is going to give me times 2, negative 3. And because I have a positive on the first 2 there, it makes it so that my signs match. And I can see 2, negative 3 and 2, negative 3 is my base vector in both cases. That means these vectors are also parallel. Let's take a look at one more. Let's say I gave you u is negative 7, negative 1, and v is 2, 14. Again, I'm going to pull out that GCF. And I want to make that first number positive. Just always go with that. It will make your life a little bit easier. So in this case, for u, I'm going to pull out a negative 1 from both. That gives me negative 1 times 7, 1. Now for v, what can I pull out of both 2 and 14? I can pull out a 2. When I do that, I get 2 times 1, 7. Now, these might look similar, but they're not the same base, okay? So 7, 1 does not match 1, 7. So that means that these are not parallel. And that's how you can define and find parallel vectors.